All right, this is the Chapter 2 review video for polynomials and synthetic division and finding zeros. So if you need to pause it, I'm going to kind of go fast. If you need to pause it, go ahead and pause it where you need to and join me. Make sure you have a graphing calculator ready to go. All right, find the vertex is negative b over 2a. So number one, we're going to find the vertex with negative b over 2a, which is negative b is 14, all over 2 times the a value, which is negative 2. That's negative 14 all over negative 4. That's 7 over 2, or 3.5, I believe. 7 over 2, and I got it. Then I take that 7 over 2 and I plug it in. Negative 2 times 7 over 2 squared plus 14 times 7 over 2 plus 1 will actually find the vertex. So at that point, you can go to your calculators. You could use 7 over 2, or you could use 3.5. So I'm going to negative 2 times, I'm just going to use 3.5 squared plus 14 times 3.5 plus 1. And I got 25.5 for that. Now, those are kind of funky decimals, 25.5 and 3.5. Luckily, I have my graphing calculator, and I can actually test to make sure that vertex is right by plugging the equation in and then simply just tracing it. So I'm going to go to y equals, and I'm going to plug in the original, negative 2x squared plus 14x plus 1. So I have it input into my graphing utility, and then I'm going to hit the graph button, and I'll see if I got the right answer, see if I got the right vertex. You really should not miss these because you can always plug it in on your graphing utility. So I'm going to zoom back to my standard screen. And I got that, which means the vertex is over and then up quite a bit. Well, if I trace this 3.5, I should get 25.5. So I'm going to trace 3.5, and I got 25.5, so that tells me I did my math right. So the vertex is at 3.5 comma 25.5, and I got it. All right, axis of symmetry. I'm just going to draw it a little bit. It's up and down like this. The axis of symmetry, just fair warning, I do take it point off if you don't label it correctly. It goes like this. It goes through 3.5. The axis of symmetry is at x equals 3.5. Does it have a min or a max? Don't answer with yes. Answer with which one it has. It has a max. What is the value of the min or the max? The value of the max is the vertex. So it has a max at 3.5, 25.5. And I got most of the stuff I need off there, except for the zeros. And zeros graphically are these spots. And all you do on your calculator is you'd go there and you'd zoom in. Well, I can tell one of them, it looks like it goes right through 0. And then the other one is 1, 2, 3, 4, 5, 6, 7.1-ish. So there's one that goes through 0, and then there's one that goes through like 7.1. So all you got to do is find those zeros, 0 and like 7.1-ish. And we found all of the stuff for that quadratic. Number 2, revenue earned in dollars from producing a gift box of candles is given by this equation, where P is the number of candle boxes that were produced. What is the number of candle gift boxes should be produced for a maximum profit? Maximum and minimum profits on any quadratic happen at the vertex. For instance, on this one, I would have had a max there. So if it's looking for a maximum profit, I notice it's an upside down parabola. So this thing is going to be something like that. And if I'm looking for the max profit, I'm looking for that little vertex up there. So I'm going to do negative b over 2a, negative 300, all over 2 times negative 20. That's 300 over 40. All right, so 300 over 40. I got 7.5 for my answer. 7.5. I should probably round that. The one on your test will come out even. This one came out decimal. I think I'm just going to leave it as a decimal on this one. but that vertex won't be a decimal on your test. But then I'm going to plug that value in, and I'm going to find what that max profit is. So negative 20 times 7.5 squared plus 300 times 7.5. And then I run the numbers. So I'll quit out of that. Negative 20 times 7.5 squared plus 300 times 7.5. And I got 1125. All right. It asked me questions. It asked me for the number of candles, and it asked for me the profit. Well, the revenue gives me the profit. So when I plug that vertex in, this is the maximum profit. It's 1125. And then the number of candles or candle boxes that were produced would have been 7.5. And like I said, that should probably be rounded. We can't really get 0.5 of a candle, but I'm going to leave it like that. It'll come out better on your test. All right, graph each on the same axes. This is important. Track the dot. If you don't track the dot, I'm not giving you points for it. So here's what I know. It's a U. It is 4 to the left, down 2, upside down. Here's my dot. 4 to the left, down 2. There's the dot I need to see. It's upside down. It's Johnny T, right 3, up 2. Right 3, up 2, Johnny T. It's fourth power. It is still a U-shaped. It's got a 4, so left 4. It goes up 2, left 4 and up 2, still U-shaped, and the 3 makes it skinnier. So I'm going to go left 4, up 2 here. Left 4, up 2. Fourth power, still U-shaped. This should be a skinnier shaped U, something like that. And the last one, odd powers. Again, a Johnny T that goes right 3 and down 2. Right 3, 1, 2, 3, down 1, 2. Looks like that. And this Johnny T has a negative in front, which means it's going to flip over that axis. And it's going to be something like this. Okay? And we have them. And I need to see that dot. This dot needs to show up on all of these problems like that. All right. B, circle each equation above that has no real zeros. This one doesn't touch the axes. It has no real zeros. That would be this one here has no real zeros. And then this one down here has no real zeros because it also doesn't touch the x-axis. That one also has no real zeros. So those two equations, because there are no x-intercepts on each one of those, I picked those two out for no real zeros. All right. Let's keep going. This one says, state the left-hand behavior and the right-hand behavior. And I want to make sure you state it in the proper format. So I don't really care if you plug it in on your graphing utility. You're going to have the ability to plug it in on this and see what it looks like. I don't even need to do that because here's what I know. X to the 5th, whoosh, upside down, whoosh, and then it wiggles. I don't even know how much it wiggles. I don't care how much it wiggles. It's Johnny T that goes something like that. I don't know. Johnny T, odd exponent, negative flipped it, and it wiggled. So I know it's going to look like that, and I can answer the equations. If you're not sure, just plug it in and look at it. Here we go. The left side behavior. As x goes to negative infinity, my function f of x goes to positive infinity. Let's go to the right. As x goes to positive infinity, as I go to the right, my f of x goes to negative infinity. I go down. So left up, right down. I got it. Okay? Next one, everybody's favorite, long division. Here we go. I have x squared. This is not a 1. If that was a 1, I could use synthetic, but I can't on this one because it's x squared. X squared means I'm going to use long division. So here we go. X squared minus 3 into x to the 5th minus 3x cubed plus 4x squared minus 6x plus 3. And I'm going to do the division. All right. X squared's got to become x5. It's going to take, I made a mistake. I don't have an x4. I need a placeholder. I'm going to rewrite it with that little placeholder. I made that little mistake right in there. I need 0 x4s in there, plus 4x squared minus 6x plus 3. Oh, I forgot my x3 that time. I made a mistake twice. All right, let's try this again. Minus 3x3 plus 4x2 minus 6x plus 3. Let's make sure. I don't want to make that mistake. That'd be bad. 0. Okay, that all looks right. All right, I need x squared to get x5, which means I need x3 here. Is everything okay? I got the right numbers? Okay, so I need x3. x3 times x2 is x5. x3 times negative 3 is negative 3x3. Oh, that was nice. Parentheses, subtract. x5 minus x5 is gone. 0x4 minus nothing is gone. Negative x3 minus a negative x3 is gone, because that'll be minus minus will make plus. So I got it to there. I'll bring down the 4x squared minus 6x plus 3. So I got it into that spot. All right, I need x squared to turn it into 4x squared. I'm going to multiply by a 4. So I'll put plus 4 in that spot. 4 times x squared is 4x squared. 4 times negative 3 is negative 12. I'm going to subtract. 4x squared minus nothing is gone, or minus 4x squared. Negative 6x minus nothing is negative 6x. And 3 minus a negative 12 is 3 plus 12, which is 15. So x squared won't get into x anymore, so that's my remainder. And don't put r. Here's how we're going to write it. X cubed plus 4 plus the remainder. So I wrote that down, plus the remainder, which is negative 6x plus 15, all over what did the dividing, which is x squared minus 3. All right, next one is synthetic division. And I know it's synthetic, it says divide, but I know it's synthetic division because I have a 1 here and a 1 here. So if you have 1s in both of those spots, you can use synthetic. So I look at that, and I think about my 0. My 0 out of that would be 5. And then I'll put my coefficients in the synthetic spots, which is 1, negative 4, negative 15, 58, negative 40. All right, let's try it. I'll drop the 1. That's 5. I'll add, that's 1. Multiply, that's 5. I'll add, that's negative 10. Multiply, I got negative 50. I'll multiply, I got 8, or add that, I got 8. I'll multiply to 40, and I'll add it to 0. Well, that was nice. Remainder, constant, x squared, x cubed. I got my answer to be x cubed plus x squared minus 10x plus 8. And I got it.